Okay, today we're talking about mechanisms in robots or machines or whatever it is that we're building. And basically, a mechanism is just a way for us to accomplish a certain task for our machine or robot or whatever. So, you can find these things all over in daily life. A couple examples just off the top of my head. Drill gears, okay? This is a drill that actually is a 90-degree drill, so it actually can... The handle or the motor would be down here, but the motor spins and these gears turn around. Well, this one turns this one. It actually changes that rotation 90 degrees. So the drill bit on the end here is going to spin at a 90-degree angle to the motor. So kind of cool. Another example here of a mechanism is this is the crankshaft as well as the piston setup for the inside of an engine. And here a gear would be turned in a rotational motion, and you're going to have these pistons going straight up and down over and over and over and over. So mechanisms can be used for multiple different things, and we're going to talk about what sorts of things we might use them for in our class here. Okay, so let's dive into it. What is the technical definition for a mechanism? It is a part of a machine which has two or more pieces arranged so that when one is moved, it forces the others to move too. And this can do a variety of things. Okay, one of four things it's generally used to do is either change the direction of the movement in the machine, change the type of movement in the machine, change the speed of movement in the machine, or change the amount of torque or force available to do work in the machine. Okay, so one of those four things. Let's talk about direction. Typically we talk about this when we're talking about gears. So it says meshed gears in a gear train always turn in opposite directions. Now one thing you're going to see quite a bit is we're going to talk about inputs and outputs, or driver and driven, or this one says driver and follower. And let's talk about what that means. The driver gear would be if you had a machine, whichever gear or shaft is being turned by maybe you have a handle you're turning, or a motor of some kind maybe is turning something, that would be your input or driver gear. Okay, that's the one that you are physically affecting. The output gear or the driven gear would be the one that is turning as a result of the first gear. Okay, so it says meshed gears in a gear train always turn in opposite directions. Well, these two gears are meshed. As you can see, their teeth are between each other, so they're put together, they're meshed. And if we were to turn, let's say we had a handle on this big driver gear, if we were to turn it around in a circle, this driven gear is actually going to turn in the opposite direction. Okay, so that's how you can change direction in a mechanism. You can also change the speed. There's something called a gear ratio, which we will work a little bit with, but not too much. And it says gear ratios compare the output or driven gear to the input or drive gear, the one that you are turning. And gear ratios are very simple. It just is determined using the number of teeth on each gear. So gear ratio equals the number of teeth on the output or driven gear over the teeth on the driver gear or input gear. Okay, and that'll give us a fraction that will tell us how much the speed or torque is being increased or decreased by. Now, two very solid notes here, and I'm actually going to explain a little bit more than what each bullet point says. Speed and torque have an inverse relationship when it comes to gears. Okay, so that means when one goes up, the other goes down. So if you are increasing speed in a gear train or a set of meshed gears, if you're increasing speed, the torque or force will go down. Okay, so it says if the output gear is larger than the input gear, the speed will decrease. But as I just said, the torque then will increase because they're inverse. Okay, so if the output gear is larger than the input gear, speed will decrease, torque will increase. If the output gear is smaller than the input gear, speed will increase, but torque will decrease. Okay, so let's take a look at this example, the second bullet point here. If you have a handle turning this big gear and the output gear is this tiny one, it makes sense that this one would go a little bit faster, but it's not going to be as strong as the motion that you are having the handle turn over here on the input gear. Okay, so tricky stuff. We'll see it in action. Mechanisms can also change movement. Three types of movement that we will see in our classroom. Number one is reciprocating, so that means something going up, down, up, down, up, down, up, down, up, down, over and over. So, for example, that engine, the crankshaft and pistons I showed you in the very beginning, the input motion was a turning motion, and the output was the pistons going up and down in a reciprocating. So, movement changed in that setup. Rotary is another type of motion, so that's just turning something over and over and over. So these two, rotary and reciprocating, were what was in that engine. The third type of movement is linear. That's when something just moves in a straight line, like this bar at the bottom here. If it's just moving in a straight line over and over and over, it's not actually going back and forth. When the wheel's turning in one direction, it's just moving in a straight line the whole time. Last but not least, just a page on force and torque, just to give you the actual definitions. We kind of went over it already, but force is the amount of push or pull in a straight line. So force is the amount of push or pull in a straight line. Torque, very similar. It's the amount of push or pull in a circular direction. Okay, push or pull in a circular direction. So we have a lot of stuff going on here. Remember, it all comes back to one of these four things. Mechanisms change the direction, type of movement, speed, or torque. And you can find them in anything. You might see them in, once again, a car engine or a drill. They're in the computers in front of you. They're in all sorts of things. The locks and windows in your car that you maybe get dropped off at school by. So we're going to try building some mechanisms, see what we can't figure out about these things. So go ahead and start with whatever your next assignment is.